heterogeneous catalysis. So we will learn that there are two types of catalysis, heterogeneous and homogeneous. So today we're going to do heterogeneous catalysis. Just a really quick reminder about what catalysts do and don't do. Catalysts, they speed up a chemical reaction by providing a different reaction pathway with a lower activation energy. Catalysts, on the other hand, they do not affect the yield. You don't make more product using a catalyst, you just get the product quicker, so you increase the rate of reaction. So catalysts do not affect the yield, but they do affect the rate of reaction. A quick analogy, so imagine that a cyclist has got to go from A to B, and the first pathway, the first route is over a hill. So the cyclist got to go over the hill. An alternative pathway is to go through a tunnel. So it's obvious that that route will be quicker. That's what the catalyst does. It provides an alternative route, but it does not change the destination. It does not affect the yield, the catalyst. Okay? Something that you should be very familiar with from GCSE, you know, when you had to draw the reaction profile. So here we've got the hydrogenation of ethene to make ethane, and by the way, this is an exothermic reaction where the energy content of the product is lower than that of the reactants, but you get similar profile regardless of whether the reaction is exothermic or endothermic. The delta H is called the enthalpy. Now, in turquoise, you've got the reaction profile for a reaction without a catalyst, and you can see that the activation energy, that's the difference between the energy level of the reactants and the top of that little hill, if you like. And you can see that this activation energy is higher than that of the purple reaction profile, where you see the activation energy is lower. That's what the catalyst does. It lowers the activation energy, so it makes the reaction quicker. It affects the rate of reaction. Catalyst, it lowers the activation energy by giving an alternative pathway for the reaction. So we don't need to worry about how it does it, how it provides the alternative pathway. We just need to know that it does. Now, heterogeneous catalysis, that happens when the catalysts are in different phase than the reactants. So usually in heterogeneous catalysis, the catalyst is a solid, whereas the reactants are gases. Solid catalysts, as you probably remember from GCSE, they are more efficient, they work better if they've got a very large surface area. So usually they've got this honeycomb structure that allows the catalyst to have a really large surface area. In real life also, the catalyst is made of an inert support, if you like. So usually ceramics, a block of tiles, and on which they coat the catalyst with a really thin layer of the precious metals, such like palladium, platinum, or something like that, or silver. And because the bulk of the material doesn't need to be made of that precious metal, because the reaction occurs at the surface of the catalyst, so not in the bulk. So that's why that they get round using less of the precious metal. I just want to go quickly over a little bit of the mechanism as to how heterogeneous catalysis works. You don't need to know in details, but I think it does help a little bit to know what's going on. So still my example of hydrogenation of ethene, yeah, with hydrogen. So from the little diagram, you can see that hydrogen adsorbs, so it sticks to the surface. It's not absorbed, it's added to the surface. So unlike your kitchen towel that soaks up liquid, the liquid is absorbed. Yeah, here the hydrogen and the ethene, they stick to the surface, and that's when the chemical reaction happens. So at first the reactants are absorbed, and then once the chemical reaction, when the product is formed, they call this desorption. So it's really important that the catalyst allows to the reactants to bind to its surface, but also allows the product to be released. So that's called adsorption, and that's called desorption. So that's the simplistic way of showing how solid catalysts or heterogeneous catalysis works in this case. Okay, so you've got adsorption and desorption. So important that the reactants bind to the surface, that they are adsorbed, but that the products can leave the surface of the catalyst. Otherwise, if the product occupies the surface of the catalyst, then no more reactants can bind to it. So over time, catalysts, they can be damaged. So an unwanted substance can bind to the surface of the catalyst. So it binds to the surface of the catalyst, it's adsorbed, and there is no desorption. It's not desorbed, it sticks there. So that prevents any other reactants from binding to the surface, because that surface is already occupied by this unwanted substance. So when a catalyst is covered by an unwanted substance, it's called poisoning. They say that the catalyst has been poisoned, although, as you know, it's not a living thing, but that's the term that they use. There are three heterogeneous catalysis that you need to know of. So the first one is the Haber process. The second one will be the contact process, and the third one will be the synthesis of methanol. So first, the Haber process. As you can remember from if you've done triple award, it's the name given for the process to make ammonia. Ammonia is very, very useful because you can make nitric acid from it, and from nitric acid you can make fertilizers, and that's very useful for growing healthy crops. So ammonia is made from the reaction between nitrogen and hydrogen, and in this case the catalyst is iron. I would strongly advise you to look at this if you've forgotten, or if you haven't had a chance to do this at GCSE. You can use BBC Bite Size. They do a very good explanation on this, and if you still don't understand, please don't hesitate to contact me. I'll help you out. Now, what do we need to know about the Haber process? Just that nitrogen and hydrogen are the reactants, and that iron is the catalyst, and that sulfur is the poison for that catalyst. Sulfur would coat the surface of iron, and therefore prevents nitrogen and hydrogen from binding onto the surface, making the catalyst ineffective. The second heterogeneous catalysis that we need to know a little bit about is called the contact process. So the contact process, that's the name of the process that's used to make sulfuric acid. Sorry. The catalyst is vanadium pentoxide, V2O5. Sulfuric acid is made by reacting sulfur trioxide, SO3, with water. something that I talked about when we did periodicity of the elements in period 3. We talked about the difference between sulfurous acid, which is made from SO2 and water, and sulfuric acid, which is made from sulfur trioxide and water. So when we talk about sulfur dioxide, creating acid rain, the acid rain is sulfurous acid, not sulfuric acid, which is in many ways much better because sulfurous acid is much weaker acid than sulfuric. Anyway, for sulfuric acid, we need to make sulfur trioxide, and that reaction is catalyzed by V2O5, so the reaction of sulfur dioxide and oxygen forms sulfur trioxide. The mechanism is as such, right? Sulfur dioxide is oxidized by vanadium oxide to form sulfur trioxide, and vanadium 5 is reduced to vanadium 4. Then vanadium 4 reacts with oxygen and is oxidized to vanadium 5. That's why we say that vanadium 5 is a catalyst, because here it looks like it's being used up, but here it's regenerated. So overall, vanadium oxide is not used. Okay, so it is a catalyst. It affects the rate of reaction, but it's not a reactant. So have a look at this several times, and if you are still struggling, please ask me for a little bit of help. I'm always here. Now the third one is the reaction of methanol. So methane and water, steam in this case, that's the type of reaction that's used to form hydrogen. So in the Haber process, hydrogen is one of the reactants, and that's formed by reacting methane with steam, and you get carbon monoxide and hydrogen. And now hydrogen can be used to make the Haber process, and also hydrogen can be used for hydrogenation. So that's quite useful chemical reaction. In this case, we are going to use both product of that first reaction to make them react to form methanol using chromium 3. So that's another useful chemical reaction. Methanol is a very, very useful starting material to make many other things. Okay, so that's the third one that we need to know, that chromium 3 is the catalyst for the synthesis of methanol. These three processes, they need to be known. They frequently ask you questions about that in the exam.